to the history of graphene, this is a very important topic, as I said, for all the carbon scientists. Single layer graphite has been studied for a very long time. This is also because first we need to understand the properties of single layer, then understand the properties of graphite, or then translate those properties to graphite and the effect of pi electrons. This is also studied this is also important for a lot of hydrocarbon materials. Okay, so the first time it was studied, not necessarily graphene, what you call graphene nowadays, but what is known as graphene oxide and reduced graphene oxide. This was studied by Benjamin Brodie in 1859. Okay, but the first paper on the electronic properties of single layer graphite was published in 1947. Okay, this still remains a very highly cited paper, and actually if you're interested, you should read. It's a very nice paper about theoretical calculations of the band gap of graphene with very nice explanation. Okay, now coming to the work of Millie and Jean Dresselhaus, these two scientists have also contributed significantly to the structure of graphene, like sheets and also carbon nanotubes. So basically, in the last 3 decades or so, what has happened is people also this is the case with fullerenes, people started studying carbon materials which are not 3D. So they do have sp2 or sp2 like sheets, but they are not 3D structures. One thing that we have now understood is that these materials are also very stable. In the past, it was believed that anything that is 2D may not be very stable. So last 30 years or so, we have been studying non-3D sp2 carbon materials, and this includes the range of carbon materials, the spherical structures, the tube-like structures, and also the sheet-like structures. Okay, and then also single layers and multi-layers and bi-layers, and how can you differentiate them using, for example, Raman spectroscopy. So the characterization of these materials has also been very interesting for scientists, and Millie and Jean Dresselhaus have contributed a lot of literature. There are also books written by them, review articles, and that is also something that I believe everyone should read. Okay, the term graphene, as I also mentioned, that by IUPAC it was suggested or officially recommended in 1994. However, this term was also used before by Hans Peter Boehm and his team. It was used actually in 1962, as early as 1962. Okay, it did become popular only in the late 20th century or early 21st century. Okay, there are also some other studies. So these are rather scattered studies, but you can find papers from 1960s and 70s which talk about few layer graphene. Also, they talk also about different fabrication methods. For example, epitaxial growth. Maybe we will also talk about that. So there are also papers from the 60s and 70s that you can find. In 2010, the Nobel Prize was given to Andreas Geim and Novoselov. This was given for discovering a new method of graphene preparation, and this new method is basically removing one layer of graphene using a Scotch tape from highly oriented pyrolytic graphite. For developing this method, they were given the Nobel Prize. Okay, so the point is that in parallel, so all of these things, when they were going on in parallel, also we have been developing the industrial methods of graphene production, whether it is for the purpose of making graphite or it is for the purpose of getting graphene itself. The point is that CVD methods, pyrolysis methods have been, they are being discovered in parallel, or they are being optimized in parallel. So this has also been going on for let's say 100 years, and now we have reasonably good methods to produce whether the pyrolytic graphite at industrial scale. Then you can also optimize these methods to now get single and bi-layer structures, because now that is more important to us. So this is the history of graphene that is very important for you to know. Since we are on the topic, I thought I could also introduce a few concepts of the nomenclature of graphene and related materials. And we do know that nomenclature is important. So don't say what's there in the name. I mean, we all write our names on our publications. So names are important, right? But what happens when it comes to carbon materials? It's not just graphene. Even in the past, graphite has been used in a incorrect fashion. So for somebody who's working in the field of carbon, the confusion of nomenclature is kind of unsurprising. Okay, but let us talk about graphene. So you know that a lot of bulk carbon materials, especially graphite-like materials, highly oriented pyrolytic graphite or just pyrolytic graphite, these materials will very well contain graphene-like sheets. So sheets of hexagonal structures, sp2 carbon sheets. In some cases, you will have defects or point defects. In some cases, you will not even have the point defects, especially if you're, for example, if you're taking a transmission electron microscope image, then you take the image of a very small and well-defined area. In that case, there is a high probability that you will find some graphene-like sheets or sheets of perfect hexagon. But that does not mean that this entire material should be called, graphene. Even whether or not have 3D structure or not, or in the case of non-graphitizing carbons, you may have curved carbon structures, but you will also have some short range order, so there you can also find some flat sheets. So in all of these cases, it is not bonded with one another or not. The point is that when you see a graphene-like sheet in a bulk carbon material, then you don't call that bulk carbon material graphene. The term graphene should only be used for single and defect-free layers. We will come to that. Okay, so you should also understand again why the nomenclature is important, because when we are talking about the single layer, then we are talking about one very specific set of properties which is not valid for multi-layer or even bi-layer graphene. Okay, the effect of the pi band is completely different when we talk about single layer defect-free graphene, or when we talk about any other. Even when you have two layers, you do lose that effect. So this confusion is not right. If you tell somebody these are the properties of graphene, then you should only be talking about single layers, because those properties are not valid for large scale materials. Okay. Okay. Now, as I mentioned that because graphene has become a very popular material, that is of course that is the reason that is attributed to this confusion of nomenclature. Anyway, if you are a research scholar, or even for all the students, I would say that you should use the term graphene in a very you should judge it for yourself what is correct, and you should definitely follow the recommendations. There have been several articles. I'm going to provide you with the reference to some of these articles, and you can actually find out. Also, you of course always have the IUPAC Gold Book for your reference. So whenever there is a confusion, please look up what is the correct terminology, and only then use the terminology. Even if some very popular or highly cited publications have used a wrong terminology and you think that this is not correct, then it's your responsibility to find out what is correct. Okay, so this article is the one that I was talking about. It was published in the journal Carbon. There you can find out a lot of guidelines. So I have not repeated all of them, just because there is no point. You can find out these details in the article. In fact, it's very detailed, not just for graphene, but all the bulk carbon materials also which contain graphene. There are there are certain recommendations that you might want to follow. Okay, so however, I have provided a summary here. So again, I mentioned that the term graphene, without the without another word attached to it, layer, so just the word graphene and not graphene layer, that should only be used for single layer defect free hexagonal structures, sp2 hybridized. Okay, but if you have if you see these sheets, as I said, in pyrolytic graphites or any other carbon materials, in that case you can say graphene layer. So the term graphene alone should be used only for when you are talking about single layers. There's nothing around it, so these are single layers. But if these kind of layers are found inside a bulk carbon material, then you can say that graphene layer or graphene-like structures. I personally prefer to use the term graphene-like structures, especially when I'm talking about non-graphitizing carbons, because I don't know exactly what is the extent of defects. Maybe in the transmission electron microscope I can see a certain type of defect, or I can even see a defect-free layer. But it is quite possible that in the same material at another point or another location you will have defect-containing layers, or you may even have voids, you may have a very strong curvature and so on. So in that case, I personally prefer to use the term graphene-like sheets or graphene-like layers. But graphene layer, if you can find a good graphene layer inside a carbon material, you can use the term. So remember, graphene and graphene layer are used differently. Okay, this recommendation, this publication will probably also explain this in more details. Okay. Now, I said that we use the terms like bilayer, multi-layer, few layers. So how many layers are acceptable? In the case of 2 layers, sometimes also 3, but typically 2 layers is bilayer, as the name suggests. Okay, few layer graphene is the term that is used for 2 to 5 layers. So if this is 2 or 3 layer, even up to 3, people end up calling it bilayer graphene. But then between 2 to 5, up to 5, you can call it few layer. But if you have more than 5 but still less than 10 layers, you will call it multi-layer graphene. If you have more than 10 layers of graphene, then it is not, the material should not be called graphene. It's just, then it should be called a turbostratic carbon material. Turbostratic, again, because the turbostratic arrangement of the sheets. But if you have more than 10 layers, then you're not talking about this 2D material, then you're actually talking about the 3D material, even if it is in the powder form. So in that case, you should just call it turbostratic carbon, irrespective of the defects also. When it comes to defect also, it's interesting that defect containing graphene has become a very common term. So graphene is a single layer defect free. But if you have some defects, I will be actually, in one of the lectures, I will be talking about what are the commonly found defects in these graphene sheets, and some of them have also been well characterized and defined. Sometimes also these defects induce very special properties to your graphene sheets. So in that case, if you have well controlled defects, or if you have intentionally created or induced these defects, in that case it's all right to call it defect containing graphene. But if unintentionally, if you just got a lot of defects and you did not want them, in that case that material might not be graphene at all. And again, when you say defect containing graphene, maybe you should, if again the same thing is valid if it's a single layer, you call it a defect containing graphene, or you say defect containing graphene layers in a bulk carbon material, for example. Okay, so yeah, here I have also shown it with some pictures. So the first picture here, you see, this is what you will call graphene. You will see that there is also, it's not a perfectly flat sheet, and there is some waviness. There is some natural waviness when it comes to graphene structures, because the bonds are always vibrating. So you do get some waviness. That is not necessarily because of defects. However, when you have, so defects means non-6 membered rings. When you have these non-6 membered rings, you have a stronger curvature. This kind of waviness can also be thermally annealed out. It can also be this is sort of a vibrating sheet. Okay, this is graphene. Bilayer graphene, 2 layers. Multi-layer graphene, this is an acceptable image of multi-layer graphene. So you see that these are layered structures, and they can be converted into graphite if we anneal them. But in any case, if you want to use them also directly, then these up to 10 layers can be called multi-layer graphene structures. However, if you see something like this, where you do see these multi-layer graphene-like structures, but you also have some curved carbons, or if you look at other locations in the same material, you may find something else. In that case, you call it turbostratic carbon. So on this slide, I have mentioned the curved carbon terminology. So this is something that I have proposed, and that's why I do not impose it on anyone. You may or may not use it, but I personally find it, and I'm explaining it here because I have used it in this course. I personally find it convenient to sort of group all the curved carbons together. And that is because these curved carbons do not have perfect sp2 hybridization. They may have sp2 plus n hybridization. So that is why it's easier to, in order to explain all these materials which have sp2 plus n hybridization, the term curved carbons can be used. So This is my rather personal recommendation, so it is up to you if you would like to follow. If you're doing this course, in that case, this is important in the exams and so on, I might use the term curved carbon. The point is that you can find these kind of curved carbon structures with sometimes you don't have much curvature, sometimes you have a lot of curvature, sometimes you have completely spherical structures, okay, but this is beyond the waviness of graphene. So remember that the term curved carbon should only be used when you have non-6 membered rings in your structure, and that is why you're getting the curvature. So we are not talking about the waviness. Okay. In the you will find these kind of curved carbon structures in nanoscale materials and also in the bulk carbon materials. So here are some examples. So the first one, the open cage structure that I have written, or even the closed cage structure that I have written. These kind of structures are also found in non-graphitizing carbons, but they can also be found individually. When you're preparing graphene using chemical vapor deposition or something, you may end up finding these open cage kind of structures, not fullerenes, but open cage structures. So whenever you have a lot of defects in your graphene or point defects in your graphene-like sheets, then in that case they tend to fold. And then when they have a very strong curvature, then you should not call them graphene even if they are single layers, because they do have then a lot of non-6 membered rings in them. So these are then called curved carbon structures. Okay, fullerenes of course are curved, that we know. Tube-like structures also have a certain curvature. So those can also be then included in this this category. And of course, in the case of non-graphitizing carbon, as I mentioned already, also in the case of electrospun carbon fibers, you often see these curved carbon sheets. So all of these materials then can be called curved carbon structures. So on this last slide, now I will briefly tell you what are the reading materials. So all these publications that I talked about in the case of history of graphene, you can also find these. Some of these papers are mentioned here, and then also you can. Some of these are review articles, for example. Then in these review articles, you can find the citations and read further. And then it's very important. I would like you to judge it for yourself, whether you should call graphene a new material, whether you should say that it was discovered in 2010 or 2005, because the discovery is a big word. So you should judge it for yourself. What is the history of graphene? My job here is to provide you with all the relevant literature. Now, if you're more interested in the electronic band gap and in the calculation of Hamiltonian, as I had mentioned in before, if you're interested in physics of graphene, then there are already some lectures that are available on NPTEL. So I don't want to repeat these properties, but here are a couple of lectures that are mentioned. Also, you will find small topics or lectures here and there on graphene materials or on graphene, crystal structure of graphene especially. You will find in the basic material science courses, material science engineering courses, which I had also, some of the names I had mentioned also in my previous classes.